show you how to use Desmos or any graphing calculator to really understand your work and to use it to check your work. And I also want to show you some ways to kind of work backwards. So some of us are a little bit more visual than others, so this will probably be really helpful. One thing when you're graphing in Desmos, and I just went to desmos.com, and then you can go to the calculator. You don't need an account, but you can certainly make one if you want to save your work. Sometimes in Delta Math or any real world problem, when we're talking about quadratics, you will see the equation is not in terms of y's and x's. It might have t's in it because a lot of real life problems will talk about time. So let's say I have a problem where it's giving me something in terms of t, and I've got, okay, let's say I have this real life problem. I've been given this equation, and I'm told that this represents an object being thrown up in the air. That is a very common quadratic problem because the object goes up and then it comes back down. And you'll see this -16 number a lot. One thing that's nice about Desmos is that you can zoom in and zoom out. So if you're not seeing what you want to see, it's really easy to move. I just put my finger on the screen, and because I have a touch screen, and I can move it down. If you don't have a touch screen, that's fine. You can use your mouse and move it down. You can also zoom in or zoom out, whatever you need to do. So let's say I'm being asked to find the vertex or interpret that vertex. I can see here, and this is another great thing about Desmos, is that I can just hover and I can click and I can see my vertex. And so I have kind of some wild numbers here. But let's say that this scenario that I'm talking about is represents a ball being thrown in the air. And so my x-axis is going to be my time. That's the t. And the y is going to be the height of that ball. So when I'm interpreting this vertex, I can say that the maximum height of the ball, remember we have a max because it's negative, and I can also see that the vertex is the highest point. The ball will reach a maximum height of about 19 feet or whatever units you're given. And then my time is it takes about, we'll just say we're in seconds, 0.938 seconds, or however you're told to round. So that vertex, the x value is going to be the input. It's going to be whatever your x-axis is talking about. So if the x-axis is talking about time, then this is my time. If my y-axis is talking about height, then the y value is my height. If my problem is talking about sales for my y value, then the y value is going to have to do with sales. So look at the labels on the graph when you're thinking about interpreting. As always, make sure that when you're talking, with a real life scenario problem, you want to think about, does this answer make sense? Okay. It really wouldn't make a lot of sense for, if these numbers were switched around, after 19 seconds, the ball's only 0.93, 8 feet in the air. So if you're getting things switched around, just stop and take a second and think about the context of that scenario. Now, the other thing that you can do on Desmos is we can see our y-intercept. I could also, it's honestly would be easier for me to just look at this and find the y-intercept, because I could just plug in zeros for t. Those are going to zero out, and so my y-intercept would be 5. But I can also verify what I'm thinking and look at the graph and see the y-intercepts. When I come down here, I can see my zeros. Now, in a real life scenario, if this is talking about time, I'm not going to have negative time. So a question that you might be asked is, when does the ball hit the ground? And then we could look at this x-intercept here. It hits the ground at about 2 seconds, okay? That's really everything that I wanted to show you on here. If you have a graphing calculator, a TI-84, and you would like to use that, you are more than welcome to, but you are also welcome to use this free online tool when you are being asked to use technology in a problem.